is Gaussian. So if I give you 10 random variables or 20 random variables that are independent and have the same distribution, and I add them, most likely you will get the distribution that is similar to a Gaussian random variable. So adding many random variables gives you a Gaussian random variable in many cases. And again, we will discuss this in more details when we come to the central limit theorem. But the point is, Gaussian random variable is well known and it's well used in many of the engineering applications because it describes either the result of many small inputs such that the summation of them will give you a Gaussian random variable, or in case you are looking at different sources and the summation of these sources, every one of them has a random variable that are independent from the others, then the result will be also Gaussian. And because of that, you see Gaussian random variables in most of the engineering applications. When you discuss noise and others, always Gaussian is, even if you look at the grades distribution of in large sections or in well-known national exams, القياس القدرات التحصيلي and so on, كلها تلاقيها مثل looks like this, Gaussian random variable or Gaussian distribution or Gaussian density. Okay? And because of that, we'll pay some attention, more attention to it more than others. So what does a Gaussian or a normal random variable look like? طبعا we already established the fact that a CDF or the PDF describes completely for me the random variable behavior. I cannot get more information about a random variable more than its CDF or PDF. So if I define the CDF or the PDF, I defined everything I know about the random variable. I cannot do better than that. Because I will, if I define the PDF, I will define how is this total probability of 1 distributed among the different values of X, of the random variable. Or equivalently, if I tell you the CDF, you will know that what is the probability that the random variable is less than any specific number X. Okay, and hence if I give you the CDF or the PDF, this describes the whole random variable. And in most cases, what we'll deal with is the PDF. So this is the most important part. However, they are both related, the PDF and the CDF. As mentioned before, the CDF is the integral of the PDF, or the PDF is the derivative of the CDF. But we will focus on the PDF because the PDF is more visual. We can see how does the random variable look like or behave from the graph. Now we know, for example, if I compare this curve اللي هو العريض هذا بالكيرف أزرق, what can you tell me about it? These two curves, the difference between them. شباب, الكيرف هذا العريض والكيرف النحيف. What can you tell me about the difference between them?
Disturbing values.
نعم.
amplitude.
توزيع القيم.
توزيع القيم
على الستة الأزرق.
ممتاز. يعني تشوف إنه في الديستريبيوشن الأزرق الراندوم فاريبل اللي الدنسيتي حقته الزرقاء هذه, most of the values of x are distributed among these values around the zero. تقريبا من 1 إلى -1. معظم التركيز, معظم probability lies here between -1 and 1. الvalues اللي أكثر من 1 وأقل من -1 have almost zero probability. بينما العريض هذا, you can see that the probability of 1 distributed among larger range, فتلاقيه يوصل إلى 6 وإلى -6 إلى 5 و-5 وإلى الآن لسه ما صار زيرو probability. So this اللي هو العريض, wide distribution has more values. It spans more values than الضيق هذا. So the PDF visually can tell you many things about the random variable. Okay? طبعا we'll come to that later when we come to the expectation and the standard deviation and so on. But now let's focus على Gaussian random variable. What I wanted to establish is the PDF visually can tell you, you can visually understand how does the random variable behave easily without looking at the CDF. So the Gaussian random variable is defined according to its density function. Density function looks like this. Fx of x is 1 over square root of 2 pi multiplied by sigma x squared. We'll define it in a minute. Multiplied by exponential of minus x minus ax. We'll define it in a minute. All to the power square divided by 2 sigma x squared, where sigma x squared is always positive and ax can be any number, any real number between minus infinity and infinity. Any finite number, which I mean. Now, this ax is basically what we call the mean or the average. So we'll come to mean and average and variance and all these things in more details in chapter 3. But now what you need to know about ax here is that it's the average value of the random variable. Average اللي هو الaverage معدل. Okay? And ax squared is what we call the variance. Variance is a coefficient that tells you how the random variable is spread around the average. يعني مثلا هذا random variable النحيف هذا has a small variance compared to random distribution or density العريضة. So as the larger the variance, the wider the density around ax. Okay, the larger, it means it's wider. Okay, and ax here is the average, so it's the average, which gives you it's basically the center of the density in Gaussian only. This is not necessarily true for all random variables. For in Gaussian, it's the center of the density. Let's see now. We have here several PDFs. Let's erase شوية نظف. Now, what do you think about what is the AX value for this blue density? AX يا شباب equals كم؟ الافريج
0.9
0 right? It's 0 هذه تمام. What about AX value for this العريض?
It's also 0.
It's also 0. What about for the red?
also
minus
0
2 minus 2
لا 0 نفس الشيء. شوف كيف السنتر هنا على 0 بينما هذا اللي داشت كم السنتر فاليو او الاي اكس حقه minus 2 ممتاز. So now knowing from plotting the Gaussian distribution or density you can see clearly where AX is. AX is the average المعدل تمام. الآن from the graph I cannot measure exactly يعني كذا بسهولة what is the variance. However I can compare الفاريانس حق هذا والفاريانس حق الأحمر مثلا تمام. Which one has larger variance? الأزرق ولا الأحمر؟
Red one.
The red one. The red one has larger variance. تمام. بينما هذا العريض أكثر شيء has the largest variance, right? So the variance tells you how wide the PDF or the density around the mean, around the average. فالآن what we need to understand is the value AX, it's the average أو the average بصفة عامة. لكن for the Gaussian in general for the Gaussian per se, it's the center of the density. Sigma x squared is a parameter that tells you how wide the variance, how wide the PDF around this the average is. Okay, so now if we plot the PDF in details, خلينا نشوف اللي تحت هذه. You can see that it's always, the peak is always equal to, the peak is always at AX. The peak value happens always at AX. Okay, this is the first thing. Second thing, it's a symmetric PDF. ايش يعني symmetric؟ معناها الarea under the curve to the right equals the area under the curve to the left of AX. Okay? Which means that the integral from minus infinity to AX, fx of x, dx, equals the integral from AX to infinity of fx of x. واضح؟ It's symmetric around AX. It's symmetric around AX. تمام؟ And the value, the maximum value that occurs at AX equals اللي هو الكونستانت هذا اللي جنب الاكسبوننشال. Because at AX, at x equal AX, the exponential value becomes 1. The exponent becomes 0, and hence the exponential becomes 1. So the parameter or the constant next to the exponential is the maximum value at AX. Okay? Now, from the maximum, going to the values at AX plus 1 sigma x and AX minus 1 sigma x. Not sigma squared, sigma, huh? Sigma here, sigma x is called standard deviation. Again, we'll come to it later in details. What does it mean? Standard deviation is related to, is basically the square root of the variance. الآن around AX by 1 sigma x and around AX by minus sigma x, the PDF drops to 2/3 of its value, here 0.607, divided by the same constant. Okay? So around AX by 1 sigma x and minus sigma x to the positive and to the left, to the right and to the left, you have the value of the PDF, it drops to 0.607 from its maximum value. Okay? Now the notation that we use looks like this. So x, we say that it's هذه الشرطة هذه means distributed. According to, distributed according to normal n with mu so normal with AX and sigma x squared. X is distributed according to this. AX انسى هذه mu. We are using different setup. So it's distributed according to AX, which is the mean, and sigma x squared, which is the standard, which is the variance. تمام يا شباب؟
تمام دكتور.
تمام. So what we learned here is, first of all, the equation of the PDF, the shape of the PDF. It's what we call the bell shape. كأنها جرس. Okay. The maximum of the PDF happens at the mean value. Around the mean, the PDF is symmetric, which means that the area to the right of the mean, to the right of the average, AX, equals the area to the left of the average. Equals كم يا شباب؟ كم الاريا هذه اللي right وال left؟ ايش رايكم؟
should be honest.
2/3.
لا. مين يفكر ويقول لي؟ كم؟
half.
ممتاز. half. why؟
Because the area from minus infinity to infinity should be 1, and since it is symmetric,
Exactly. It's half. Exactly.
yes.
Thank you. So basically, to the right is half, to the left is half. Now remember هذه half is إيش؟ This is the probability. هذه أول واحدة اللي ب probability that x is less than or equal ax. والثانية اللي probability الإيش؟ x is larger than or equal ax. Since it's continuous, you can put the equal anywhere. Both of them is half. تمام؟ طيب. Now the CDF looks like this. The CDF looks like this. For the same PDFs above, the CDF looks like this. فتلاحظ CDF happens to be to exceed half, sorry. happens to exceed half at the mean. يعني مثلا هذا الداشت you can see it exceeds half at the mean. ليش؟ لأن احنا قلنا above x larger than the mean, the PDF becomes the CDF, which is probability that x is less than x, becomes half. So it exceeds the average, exceeds half at the average. الثلاثة الباقيين هذول all have the same mean, which is 0, the same average, and hence they exceed 0.5 at 0.5 at the average, which is 0. تمام. You can see that the narrow PDF, the narrower the PDF, the more steep the transition from 0 to 1. لو تلاحظوا فجأة كذا طلعت ووصلت. بينما الred, you can see that the red here has more smoother transition. So as the variance becomes larger, the transition from 0 to 1 in the CDF becomes smoother. تمام يا شباب؟ نشوفوا عرض واحد هذا، شوفوا كيف مرة smooth، بطيء عشان يطلع from 0 to infinity to 1 in the CDF. أي سؤال يا شباب؟
Doctor, can you repeat the last point about the red and the red line and the blue one?
يعني خلينا نقول the smaller the variance البلو لاين هذا احنا
Yeah.
قلنا البلو line has a narrow PDF معناها الفارينس is small, right?
Yes, doctor.
When the variance is small, the CDF jumps from 0 or around 0 to 1 faster than شوف البلو كيرف هذا faster than the red curve اللي هو having larger variance. تمام؟
تمام دكتور.
And the last point I want to mention about the PDF of Gaussian is this maximum. لو تلاحظوا الماكسيمم هذه is divided by sigma x squared. So as the sigma x squared increases احنا قلنا انه الكيرف becomes wider, right? However, it becomes also the maximum becomes smaller. يعني مثلا this is with a specific sigma x. For another sigma x that is smaller, it will look like this. Smaller sigma x. So the maximum becomes larger while it becomes narrower. واضح؟ ليش؟ لأنه الarea is always 1. So if the curve becomes narrow, it has to have a peak value that is larger than if the curve is wide. آخر شيء الarea under any curve, normal curve is 1. تمام؟ أي سؤال ثاني شباب about the details of the distribution? What does every parameter mean? Okay. Now the CDF of the Gaussian random variable هذه PDF. إلى الآن كل كلامنا على PDF الشكل والكلام هذا تونا بدينا في CDF. This is the CDF. This is the PDF. Now mathematically the CDF is the integral of the PDF from minus infinity to x, which is given by this. It's the integral, طبعا الكونستانت هذا برا, stay as it is, and then we integrate from minus infinity to infinity this exponential. Unfortunately, this exponential, this integral has no closed form solution. So there's no closed form. However, we can evaluate it using some numerical or approximation methods. So we can have a table for this CDF. Okay? For example, for mu here is AX. Mu here is AX. بالعادة, when we say mu, means it's the average. With sigma is sigma. Sorry, I wrote it wrongly. It's AX. So here we can see that the PDF looks like this, and the corresponding CDF looks like this. زي ما قلنا دائما CDF exceeds 0.5 at the average. So what is the average here? It's the center of the curve. كم الافريج هنا؟ شباب؟
10.
10. Exactly. طيب. زي ما قلنا, what is the value of the CDF at AX? ارسلوا لي بالprivate chat شباب. Reply to this question on the private chat. What is the value of the CDF? شوف مين معايا ومين سرحان. At x equal AX. What is the value of the CDF? شباب. طيب يا شباب, ما شاء الله, I got many answers that are totally different than our discussion. What is the value of the CDF at x equal AX? So I'm asking, what is fx of AX? احنا قبل ما نحل أي شيء قلنا دائما نكتب الديفينيشن. What is this equal to? شباب, what is this equal to? It's probability.
Probability.
Yes. That x is less than or equal AX. And what is this equal to?
Half.
Half. ليش؟ لأنه it's a symmetric. It's the area under the curve. Right? So it's half the area. It's half. Because the whole area is equal to what? 1. Okay? طيب. So this is basically the closed form solution that we don't, the integral that we don't have closed form solution. And because of that, we can make tables for that. Okay? So we can evaluate this numerically for a specific AX and a specific, AX and sigma x squared. So we can have a table for every AX and sigma x squared. So for example, let's sigma x squared equal 3, let's AX equal 5, then fx of x equals 1 over 2 pi multiplied by 3 multiplied by this integral. And we can construct a table for every x. So if x of minus 20, I can get you the value, right? This is fx of x, and this is x. So for different value of x, I can calculate fx of x. However, this is for a specific ax, a specific sigma x squared. How many specific ax and sigma x squared we can have? ايش رايكم؟
Very limited, I think.
How many average values you can have for any random variable?
0 for any random value. variable.
for any random variable Gaussian كم average value ممكن يكون عندي؟ يعني خلينا نقول اختبرتوا انتوا الاختبار الاول طلع الافرج حقكم كم؟ خلينا نقول 70. اختبرتوا الاختبار الثاني طلع الافرج كم؟ 65. الثالث طلع الافرج 67 مثلا. So a Gaussian random variable, you can have many values for AX for different random values اتكلم عنها. For different random values, you can have different values of sigma x squared. So if I want to create a table for fx of x for every random variable, I need how many tables here? One table for every ax, one table for every sigma x squared, which is many tables to be constructed. واضح يا شباب الفكرة؟ For every specific random variable with every specific average value ax and variance sigma x squared, I need to calculate this table again and again and again. صح ولا لا؟ شباب واضح الفكرة اللي I'm trying to say here. However, what this gives me is أنا اللي أبغى table for different values of x. أبغى table that gives me fx of x for different values of x. However, this table اللي تونا we created this table will only work for a Gaussian distribution with these average equal ax 5 and sigma x squared 3. الآن لو جتني بروبلم ثاني بعدين رحت على لاب ثاني وطلع لي Gaussian with ax equals 8 and sigma x squared equals 0.2. I need to run this again صح ولا لا? In order to find the fx of x for every value, isn't it?
Yes.
Yes.
Which is too much. How many of these combinations I have? It's infinite, uncountably infinite. لأنهم كلهم هذول real numbers. So you can just see that every problem in your life, you can end up with different average value and sigma x squared, and hence you need to repeat this exercise again. اللي هو building the table. Because of that, to eliminate this, we define what we call normalized Gaussian distribution. ايش normalized Gaussian distribution? I only build a table for the normalized Gaussian distribution, and I call this fx without x, without subscript, f of x. F of x is basically the CDF for Gaussian with ax equals 0 and sigma x squared equals 1. So I only make a table for this CDF. اللي هو normal, we call it normal, with 0 and 1. 0 is ax and 1 is sigma x squared. I only make one table, and it's already there in your textbook and in almost all textbooks that are discussing Gaussian distribution. I only build one table. So I make numerical integration of this function that has ax equals 0 and sigma x squared equal 1, and then I make this table. Now, if I want to calculate for a specific ax and specific sigma x squared, what do? I make a change of variable. I define u to be zeta minus ax divided by sigma in fx. So fx of x here اللي هو اللي كنا نتكلم عنه فوق for a specific ax and sigma x squared equals لما اسوي change of variable مقارنة باللي هنا I get basically this. The integral is up to x minus ax divided by sigma x with the same integral. So the only thing that changes is the limit. This is equal to f اللي هو اللي already the function the CDF with ax equals 0 sigma x squared equal 1 لكن evaluated at x minus a divided by sigma x. So if I want to calculate the CDF for a Gaussian random variable with ax and sigma x squared, I use the standard normalized table اللي هو normalized distribution evaluated at x minus ax divided by sigma x. تمام؟ Let's have an example. واضحة يا شباب الفكرة؟ And this thing here اللي هو هذه normalized distribution looks like this. The table looks like this. This is x. هذه x 0, 0.1, 0.2 up to 3.8. وهنا fine details of x. So if you want the value for 1.11, so this you go 1.1 and then 0.1. So this will be, this is for 1.11 value for x. Okay. تمام. If you want to read 2.05, so you go to 2 and then 0.5. And here you go. So this is f x equal 2.05. This is the way we read it. فهذا التابل في عندك ال x value and the details of x. So this is the second decimal. Second decimal of x. This is the
Doctor,
first. تفضل.
the final number is what? 2.09798.
يعني مثلا for إذا أبغى أن ال value of x equal 2.05 it's equal to 0.9798 هذا. بينما ال f of x equal 1.1 equals 0.8665. واضحة how to read التابل؟ طيب I need you to send me over the private chat f of 0.56 over the private chat. F of 0.56.
Doctor, can you repeat the question?
Send me from the table, right? Find f of 0.56 for this value, 0.56. What is f of 0.56? Go to the table and find the corresponding value. خلاص شباب؟ what is the value? We go to 0.5 ممتاز and then go to 0.06 اللي هو second decimal
7123
0.7123. Thank you. تمام? So this is the way I read the table. أي سؤال يا شباب how to read the table? So the y-axis here is the value of x. The x-axis is more details in the second decimal of x. شباب, any question? How to read this? Because this you will it's always a question in every midterm and final.
The table will be given, right?
Of course, طبعا the table will. It's not to memorize it for sure. لكن you understand how to read it? What does it mean? So now what is this? This is equal f of 0.56. What does it mean? It's the probability that x ولا خلينا نسميه y عشان ما تلخبطوا بين x و y is less than or equal 0.56. And what is y? Y is a normal distribution with zero mean and variance equal to 1. واضح? So if I have a zero mean and variance equal to 1, then the probability that this random variable y اللي هو اللي zero mean و variance 1 is less than 0.56 equals 0.7123. واضح؟ Now let's have an example so that it's clear to you how to use this. A Gaussian random variable with ax equal 3, so the average here is equal to 3, and sigma x is 2. sigma x مو sigma x squared يا شباب, you need to لازم تميزوا بين sigma x و sigma x squared. ايش العلاقة بينهم؟ The square root of this, sorry, sigma x square equals sigma x simply square. هذا يسموه standard deviation. Standard deviation. وهذا يسموه variance. لازم تفرقوا بين الاثنين. طبعا لما نروح على chapter 3 we will go into details of what is each one and how is defined and calculated and so on. But simply variance عبارة عن the square of the standard deviation. خلاص? Now I give you a random variable, Gaussian random variable with the average equal 3 and standard deviation sigma x equal 2. And I ask you evaluate the probability that x is less than or equal 5.5. So what do? Simply I normalize. I subtract from x اللي هي 5.5 3 and I divide by the standard deviation. So I get 1.25. So if x of x اللي هي عبارة عن 5.5 equals the probability that x is less than or equal 5.5. صح? Which is equal to f. This is not fx, this is f, which is the CDF of the normalized distribution. Evaluated at 1.25. من وين جبنا ال 1.25? From here. We took x, subtract from it the average, which is 3, divided by the standard deviation, which is 2. We get 1.25. Now we go to the table and find f of 1.25. This will give me fx of 5.5. x هنا عبارة عن ايش؟ Normal. What is the mean of x يا شباب? What is the average? x هذا عبارة عن ايش؟ What is the average? 3 and standard deviation of, so the variance of كم؟ الفارينس كم يساوي؟ 4. ممتاز. So this is ax and this is sigma x squared. So x here is this distribution, normal distribution with كذا. f here has a CDF, f here is the CDF of the normal with zero mean and variance 1. So now fx of 5.5 equals f of 1.25. What is f of 1.25? How to find it? أعطوني يلا كم الvalue. I go to 1.2 and then R5, which is this. And this is equal to 0.8944. So the probability that this random variable, this Gaussian random variable, is less than or equal 5.5 is equal to 0.8944. واضح؟
واضح.
أي سؤال يا شباب؟ How did we do this? Okay. Another example. The height of clouds above the ground is a Gaussian random variable x with the average equal 1830 meters. So average حق السحب فوق السماء في السماء الهايت حقها is 1830 meters, and the standard deviation is 460 meters. يعني لو تشوفوا الكلاود كذا شكلها اوكي، الافريج حقها الارتفاع حقها is 1.183 meters الهايت، and the variance is or the standard deviation is 460. And I want you to find the probability that x اللي هو الهايت of the clouds above the ground is larger than 2750 meters. To calculate this احنا عندنا ال CDF ما عندنا larger than، عندنا less than. So probability that x is larger than a specific number equals 1 minus x less than or equal that number. Right? It's 1 minus that. لأنه this is a complement event لو تتذكروا. And the probability that x is less than this number equals fx of the same number 2750. تمام؟ I don't have a table for this random variable. What I have a table is f for f with normal of 0, mean, and variance equal 1. So I take this number, I subtract from it the mean, and I divide by the standard deviation, AX. Sorry, sigma x. So if I do this, 2750 minus 1830 divided by 460, I get 2. So whatever inside here is equal to 2. So this is 1 minus f of 2. What is f of 2? Let's go back to the table. F of 2 was added 2. 0.9773. So it's 1 minus 0.9772 ولا 3 3 المفروض ما فرق, which is 0.0228. Okay. So you know now, you understand now how to use the table, how to calculate the a specific probability for the Gaussian random variable with any mean, any average, and any standard deviation or variance. طيب.
Yes, doctor.
What if I give you sigma square بدل sigma؟ يعني إذا أعطيتك نفس المسألة لكن أعطيتك sigma square, what you will do for that?
The root.
Take the root.
You will exactly, you will take the square root of that. دائما انتبهوا ايش المعطى. في بعض المرات ممكن اسوي لك تريك، اعطيك سيجما سكوير، اعطيك الفارينس ما اعطيك الستاندرد ديفيشن. So you need to take the square root and then divide. So this is equal في الاكزامبل هذا it's equal to 0.028228. ايش يعني؟ It's 2.28%. So if you look at these clouds, 2.28% of the time you will find a cloud that is larger, الهايت حقها larger than this number. أعلى من 2750 متر. Only 3%, less than 3%, less than 2.5%. Which means that معظم الوقت السحب الهايت حقها أقل من كذا. تمام؟ The last point that I would like to make here is related to the non-biased distribution. If this is the curve of the Gaussian, this is AX. Sorry. خلينا ناخذ الستاندرد. So this is normal with 0 and 1. Now what is f of x? This is x. It's equal to the probability that x is less than or equal x, right? So this is, if this is x, خلينا ناخذها a بلاش x عشان ما نلخبط شباب. بلاش a. سميها u. F of a specific number u. What is this f of u? If this is u, it's simply the area under the curve under the tail نسميه. هذه هي f of u. Okay. تمام يا شباب. It's basically the area under the tail نسمي هذا التيل ذيل ال distribution. Just to visualize what you are doing. تمام. طيب الآن أنا عندي هنا u is negative صح؟ لكن أنا في التيبل ما عندي negative، إيش أسوي؟ شباب.
ولأنها سيمتريك بتصير نفسها بالجزء.
Exactly. لأنها symmetric. This tail is equal to this. This is f of minus u. خلينا بس نلخبط الدنيا، خلينا نيجاتيف نيجاتيف والبوزيتيف بوزيتيف. f minus u وهذه u f of u. Okay. Sorry. This is 1 minus بس دقيقة شوي. This is معلش خليني بس أمسح كل شيء وأرجع أرسم مرة ثانية. معلش. If this is the curve and this is the 0 and this is u, f of u is this thing, right? Okay. Now if I want f of minus u, طلع لي المسألة طلع لي آخر شيء negative. I don't have a negative value here في التابل. So what I'm interested is here minus u. أبغى أنا f of minus u. كيف أجيب f of minus u يا شباب؟ إيش رأيكم؟ أنا هذا اللي أبغى من هنا وطالع. This is what I want. What I have in the table is all this shaded curve. هذا كله. f of u. How to find f of minus u من التابل؟ رأيكم؟
1 minus f of u.
Yes. Why? لأنه هذه الاريا هي نفسها هذه الاريا. And what is this area? It's 1 minus f of u. So this is equal to 1 minus f of u. واضح؟ شباب. Clear? Because you will have problems with negative. So you need to be able to find the negative. Using the symmetry, this area equals this area. And this area اللي هنا اللي على اليمين equals 1 minus fu اللي هي the rest of the curve. خلاص؟ I think time is up.
Excuse me, doctor, I have a question.
تفضل. Go ahead, please. تفضل. Time is up. Anybody who wants to leave, you are free. تفضل.
I've
Yes.
seen the syllabus and the homework, the weights of it's around 15%. And I was wondering, the submission is not like, there is no links or something like that, or like it's
There's
something
no
you do.
submission. الشباب اللي حضروا معنا من بداية السمستر من syllabus, there's no submission for the homework. The quiz will come about the homework. Okay, you need to solve the homework. I will upload the solution. I will not grade the homework. It's up to you. However, the quiz, make sure that the quiz is about the homework.
All right, I understand. So the quizzes will take the weight of the homework, right?
Yes, we'll take the weight of the homework and the quiz as well.
So it will be around the 25%.
لا هي 15% الكويزز. Check the syllabus please. هذا كله تكلمنا فيه في أول أسبوع.
Okay, thank
The
you.
syllabus is
Because
already uploaded there.
Yeah, I know. I remember you saying something like that, but I was surprising when I say the homework have some weights. So I just wondering if there is submission that I
لا
didn't
لا لا
know
لا
about.
هي جاية في الكويز. لا ما مر عليك شيء. جاي داخل الكويز. بس make sure الله يخليكم to solve it. Doesn't mean this is not to be solved.
Yeah, it's of course it's for
هذه
practice.
لأنه عشان تفهموا الكونسبت أكثر. I think practice will help you a lot.
Yeah, that's right. Thank you, doctor. See you
الله
later.
يوفقك.
Have a nice day.
توفيق. حياك الله. أي سؤال ثاني يا شباب؟ Okay. See you إن شاء الله. Thursday مع السلامة.